So a curve in the xy plane is defined implicitly, so I'm going to find the derivative. So in order to find the derivative, I'm going to have to use the product rule here. So u is 2x, v is y. So derivative of u is 2, the derivative of v is y prime. So derivative of u times v plus the derivative of v times u. The derivative of y squared would be 2y times y prime. And the derivative of negative 3x is negative 3. So I'm going to go ahead and factor out a y prime. And I'm going to subtract 2y from both sides. And then I'm going to divide. So there's my derivative. In part B, we're trying to find the equation of the tangent line when x is equal to 1. So the first thing I need to do is I need to find y. So in order to find y, I'm going to use my original function. And wherever I see an x, I'm going to substitute a 1 and solve for y. I'm going to have 2y minus y squared equals to negative 3. So what I'm going to do is I'm going to add y squared to both sides, and I'm going to subtract 2y from both sides. So I get y minus 3, y plus 1. So I'm going to have 2 points, y equals to 3 and y equals to negative 1. Okay. So in my first point, 1 comma 3, my slope is going to be, so I'm going to substitute wherever I see an x, I'm substituting a 1. Wherever I see a y, I'm substituting a 3. So I'm going to have 9 over negative 4 or 3 halves. So my equation of my tangent line the second point is going to be 1 comma negative 1. So my slope, again, I'm using this equation to find my slope. It's going to be negative 1 over 4. So the equation of the tangent line so I have two tangent lines that are going to be tangent when x is 1. Okay, part C says find the x-coordinate of each point on the curve where the tangent line is vertical. So in part C, the tangent line is vertical when the slope or the derivative does not exist. So what we're going to do is we're going to look at our slope and we want to know when my slope is not going to exist. So the slope is not going to exist when the denominator is equal to 0. So we can't have the denominator equal to 0. So I need to think of points such that if I substitute my points, 2x minus 2y is going to equal to 0. Okay. So if I solve it, I'm going to have x equals to y. So basically, the points which my slope does not exist would be when x is equal to y. So if x is equal to 1, that means that y is equal to 1. So at the point 1, 1, my slope or my tangent line is vertical. At the line 2, comma 2, my tangent line is vertical. 3, comma 3, my tangent line is vertical. So there's going to be many points such that my tangent line is going to be vertical. So a particle moves along the x-axis so that at any time its position is sine of x. Find the average rate of change. So my average rate of change is my slope formula. So I'm going to have x of b minus f of a over b minus a. So here's a, here's b, and here's my function. I'm going to have sine of pi over 4 minus sine of pi over 3 all over pi over 4 minus pi over 3. So sine of pi over 4 is the square root of 2 over 2. Sine of pi over 3 is the square root of 3 over 2. I'm going to find common denominators. So I'm going to have 2 square root of 2 square root of 3 over 2 times 12 over negative pi. Basically, I just took the reciprocal and multiplied it. So notice how my 2 and 12 will cancel. So I'm left with 6 square root of 2 minus square root of 3 all over pi. So that would be my average rate of change. Part B says find the velocity. So to find the velocity, I'm going to have to take the derivative. So derivative of sine is cosine. And I want to find my velocity when x is pi over 4. So cosine of pi over 4 is the square root of 2 over 2. And find the acceleration. So the acceleration is the second derivative. So the derivative of cosine is negative sine. And negative sine of pi over 4 is negative square root of 2 over